Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of the viewers of this video. So today we are going to discuss about chapter 4 in form 5, polymers. So first thing first, we need to know what is polymer actually, and where's the polymers come from, and what's the type of polymers, the reactions, also uses of polymers, and also the effects of environment. So what is polymer actually? So polymers is a long chain molecule that made up of combination of many repeating basic units. So the basic unit of polymers is monomer, means like monomer plus monomers and becomes polymers. So source of polymer means like we need to know where is the polymer comes from. So the source of polymer have two, which natural polymer and synthetic polymer. So natural polymer is naturally available and can be obtained from surroundings. For example, starch, protein, and cotton. While synthetic polymer is a man-made polymer through chemical reactions in laboratory or even factories. So the example of synthetic polymer is nylon, polyethylene, polystyrene, and PVC. So guys, this is the example of source, polymer, and monomer. I copy down them into the table. So guys, we should know the types of polymers. So we have three types of polymer, which is thermoplastic polymer, thermosetting polymer, and elastomer polymer. So the thermoplastic polymer can be recycled and can be repeatedly molded upon heating. When heated, it melts and it becomes solid when it cools. While thermosetting polymer can't be recycled and can remold after heating, and it is normally disintegrate and burn upon heating. While elastomer polymer have a properties of elasticity and can be stretched and back to its original shape when released. These are the examples of thermoplastic polymer, thermosetting polymer, and elastomer polymer. Polymerization reaction consists of two, which is addition polymerization and condensation polymerization. So in addition polymerization occurs when monomers that have double covalent bond between two carbon atoms react with one another. While condensation polymerization involves at least two different monomers, and the byproduct should be a polymer, water molecule, or a hydrogen chloride molecule. These are the examples of addition polymerization. So I just insert 4 examples right here in the form of table. During addition polymerization reaction, the double bond is opened and the monomers are added to the chemical chain and produce a polymer. For example, ethene molecules combine together and becomes polyethylene by polymerization reaction. This is the example of condensation polymerization, which produce trilene and also water molecules as the byproduct. As you can see, 1,2-ethanol and 3-lactic acid are combined together. Both of them are a different monomer and then combined together then becomes trilene and water. This is the condensation polymerization, which produces nylon. When 1,6-hexane diamine and decanediol dichloride are combined together, then it becomes nylon as a polymer and also the hydrogen chloride molecules. This is the process of producing nylon. These are the uses of polymer in daily life. We use polymer as medical apparatus, plastic bags, and also nylon, because polymer have several unique characteristics. For example, polymer is a good heat insulator, and it also inert and unreactive, which is it's safer for us to use it everywhere and every time we want. And also, polymer is high heat resistance and also hard, strong, and lightweight. Polymers and the environment. So some polymers are durable and take a very long time to disintegrate that cause the serious pollution. So, as a human, recycling is the best method and the easiest way to be practiced by consumers so that synthetic polymers do not end up in landfills. So, in degradable polymers, additives are added to ensure the plastic to decompose by bacteria or by light. So, as the result, plastic products will decompose faster and will reduce the plastic dumping issue in landfills, and that is safer for the wildlife. Now we move on to the next subtopic 4.2 Natural Rubber. Rubber and history. So rubber tree with the scientific name Hevea brasiliensis were brought to Malaysia in 1877 and continue to be developed here. Do you know that latex is a white fluid produced from rubber tree when the tree bark is tapped? So the natural rubber that found in latex is a natural polymer named polyisoprene. So these are the characteristics of natural rubber. Now we go to coagulation of latex. So latex is collected in liquid form for processing, and it can be left to coagulate and to be collected a day after it was tapped. Latex will start to be solid and coagulate after a few hours once it exposed to the air. Do you know why this process happens? We are going to discuss about it in coagulation process of latex. So we look at the number 1. The negatively charged protein membrane causes rubber particles to repel each other. Then hydrogen ions from acid neutralize the negatively charged protein membrane. Then the rubber particles collide with one another that cause the protein membrane to break. So the rubber polymers combine with one another that cause latex to coagulate. Latex coagulation prevention. So commonly you use alkaline solution to make sure that the latex coagulation will not happen. So alkaline solution like ammonia, is used to prevent coagulation of latex. Why we use alkaline solution to prevent the coagulation of latex? Well, alkaline solution consists of hydroxide ions, which will neutralize the acid produced by bacteria. So the protein membrane of rubber remains negatively charged, and the rubber particle will repel when they draw each other. If you notice, latex coagulation prevention is to use alkaline solution, while latex coagulation process is to use acidic solution. Vulcanization of rubber is a process producing a rubber that is more elastic and better quality compared to natural rubber through the production of cross-link between the polymer chain. For example, we use sulfur. The double bond of carbon will react with sulfur to produce sulfur cross-link. Then the rubber finally becomes stronger. Alternative vulcanization method. This method can't be used to certain types of rubber like synthetic rubber that don't have double bond of carbon atoms. So the rubber produced after vulcanization without sulfur is more safer to the environment. For example, we use metal oxide and peroxide, and we also use irradiation method for this vulcanization method. So this is the characteristics of vulcanized rubber and unvulcanized rubber. These are the properties of vulcanized latex. So unvulcanized rubber, before stretching, during stretching and after stretching are quite different. While vulcanized rubber, before stretching and after stretching, the shape and original size are remain unchanged after release. So this means that vulcanized rubber is more elastic compared to unvulcanized rubber. But how this process happens? So, the formation of sulfur cross-link reduces the double bonds of carbon in vulcanized rubber, which makes it harder to oxidize. So, sulfur cross-link prevents the rubber polymer from sliding when stretched and back to its original shape when released. This condition provides vulcanized rubber to be more elastic and resistant to high heat. This uniqueness makes the vulcanized rubber produce so many products compared to unvulcanized rubber. This is the experiment to know which one is more elastic between vulcanized rubber and unvulcanized rubber. this is the last subtopic for this chapter, 4.3 Synthetic Rubber. So what is synthetic rubber? So synthetic rubber is a synthetic polymer that elastic in nature or elastomer polymer. So these are the few characteristics of synthetic rubber, which is hard, elastic, heat insulator, resistant to heat and oxidize, and resistant to chemicals. So these are the synthetic rubber characteristics and uses. So synthetic rubber can produce a lot more of products like tire, gloves, medical implants, automotive components, hose, and a lot more. Uses of rubber and environment. So synthetic rubber took a long period of time to decompose and make disposal difficult. So vehicle tires are some examples of products of synthetic rubber that need to be disposed in a large quantities. While natural rubbers are easily decomposed by bacteria, but the use of natural rubber is limited since the natural properties are less resistant to heat and chemical solvents. So guys, chapter 4 is end here. And don't forget to do some research and revisions about this topic because this topic is quite awesome and fun to learn. So I hope you guys will have a spirit towards learning, and also I wish you good luck in your XPM and your examinations. Nothing impossible to a willing heart. Well, thanks for watching and see you next time.